All right, well, what we talked about yesterday, we just need to review a little bit. So, I know you guys have the notes in front of you, but if you remember, we went through a solution and what it is. And the solution is made up of two things. You have a solvent, usually in greater quantity, and you have a solute that is going to be broken down into either ions or molecules. So solutes are, if they're molecular, they're broken into the individual molecules, like sugar molecules. And if they're a solvent, they're broken down into ions. And we'll kind of show that a little bit today. Now, what's the characteristics? They don't settle out. You can't tell one part from another. They're all one phase. They're either all liquid, all solid, all gas. And you can't separate it by filtration. Okay, we know that about a solution. All right, good. So then, we have two other types of mixtures that are not homogeneous, and they would be colloid. Colloids are heterogeneous. They will reflect light. So colloids, any colloid that you try to shine light through, you'll see the beam appear because the particles are basically reflecting it in all different directions. So that's called the Tyndall effect when that happens. And then we have a suspension, and their particles are the largest, and they can be filtered out, and they'll settle out as well. Okay? So they can be filtered. They may scatter light, but the biggest thing is that they will eventually settle out if you don't stir them and agitate them. Okay? I think there's some medicine at times like that. I think we used to get amoxicillin, and if you'd leave it, it kind of would separate, and then you'd have to shake it, and then you'd have to get your pipette full or your spoonful and that, because I think it was to the point where I think it was like a suspension almost, that was that concentrated, that you would have to use it that way. Okay, so then we also talked about, hey, if we take some of these solutions and we test them to see if they conduct electricities, if it's a solid that's ionic and it dissolves, it's an electrolyte. So all ionic compounds, and you guys know what an ionic compound is, right? What's a combination of what? So what's an ionic compound? You have to have two things. What are the two things you have? Come on. What two things are put together to make an ionic compound? Yes. Metal, non-metal. Or you could also say cation and anion, that they're charged. Okay? So anything that's a positive charge ion or negative ion, and they come together, that would be considered ionic. Molecular, when I say carbon-based, it's probably carbons and hydrogens and some oxygens in there. They're not all going to be perfectly non-electrolytes, but a lot of them would be. Like sugars, C6H12O6. Okay? All right, so the new stuff. We're going to talk about things that affect the rate at which something dissolves. Rate means speed. How quickly can you take a substance and mix it thoroughly to make a solution where you don't have any particles left over? Alright? So, there's three things we can do. Alright? Does anybody know the three things that we can do to make a solid disappear quickly in a liquid?
Tearing them apart.
Okay, how do you tear them apart? When you say tear them apart, what do you mean?
Like making like if you have like big solid, try to make it like smaller.
Right. You would take and want to make it smaller. So, we have what we call mortar and pestles. Okay, I don't use these very often, but these are strictly for the purpose of taking a solid like rock salt, like this, and making it smaller. Okay? And the whole purpose of doing that, and I have to do that with some solids because if I didn't, it would take forever for them to and a lot of times this is used to be on stores, on the front of stores. Where would you see this picture? Pharmacy. Because they would take solids and they'd do mixing within the bowl here and make smaller. I don't think they probably do that anymore. But it's a process of making them smaller so that you can, just like Gabe says, break them apart so that they're smaller pieces. Okay? And if you notice the space or the area taken up by this solid versus this solid, can you tell the difference? Which one has more surface area? The small particles. And they talk about surface area. Why is surface area important? Well, it's because there's more of it in contact with the solvent. If you get more contact between it and the solvent, then you have a situation where that would increase how quickly it would dissolve. Okay? So what's another way to increase how quickly something dissolves? Yes? Temperature? Yeah, the temperature, right? So I have really hot water here, and if I have crystals that I have, let's say I have 2 crystals here, they're similar sizes, and I put it in the hot water, and I let it sit. I'm going to put it in cold water and let it sit. We'll see which one dissolves quicker. Okay? So I'm just going to let it sit, and I'm not going to stir it. And then we'll take a look at it every once in a while and see which one dissolves quicker. Okay? You could even, which is neat, you could even look at the one that's hot, and you can see the salt particles rising off of it. Okay? So you can tell right away that those salt particles are really rising off of that, and we'll see which one dissolves quicker. Okay. So we have 2. We need one more. It's the easiest one. What? What's that? Pressure really doesn't have effect on dissolving rate. You think it would. More pressure would increase the rate, but that's just gases. And so it really doesn't have an effect on that. Yes? Stirring. Or agitating, or swirling, or shaking. Those would be ways in which to increase how quickly something dissolves. Like at home, when you guys cook, right? You stir in an ingredient. You don't just put it in there and leave it. You stir it in. Okay? And so stirring or mixing. And you guys ever have one of those bullets where you make shakes? Or those are really nice compared to a blender. You put everything in that bullet and put it on there. Boom. It goes and it's mixed up within a matter of 10 seconds or so. Okay? Grinds everything up. Makes it into smaller pieces. Grinds it up. So those are the 3 factors that affect the rate of dissolving. So I'm going to leave this up here for these first 2. You guys can go ahead and write those down in your notes. So where we are in our notes, so heating would be the third one. Okay, Mickey Mouse, right? So when something is saturated, it means it's maxed out. Can you give me an example of something, kind of analogy of that, where something is totally full of something and it can't take anymore? We call it saturated. Just a normal example. Yep. Huh? I didn't hear what you said, Isaiah. Right, the soil. Right? You say water, well, I watered. The soil can only hold so much water, and then it's just going to start releasing on the other side, right? Okay? What else? That's a good example. What else? I always think of towels. Like if I had a towel, and this isn't much use when it's completely wet, right? When it's dry, it can be used. It's good. When it gets wet, and you try to dry yourself off with a wet towel, it doesn't do a whole lot, does it? Okay, because it becomes saturated with water, and it can't take any more water away from your body if the towel's wet. So anytime we talk about something, a solubility of something, it has to be saturated, which means it can't hold any more solid. It's to the point where it can't hold any more solid. Like this salt, for example. You know, how much can I put of this salt in here before it's maxed out? There's a table that tells me. This is about 20 degrees. There's a table in the book that says about 35 grams of salt can fit in 100 grams of water. And that's when it's saturated. What if I put 40 grams in? Then there's going to be 5 grams that doesn't dissolve. And what if I put 50 grams in and stir really fast? There's going to be 15 grams that are not going to dissolve. Okay, so that's the point what we call saturated. Okay, at that point where it doesn't dissolve anymore. Okay. All right. So I'm going to go ahead. When you can go ahead and get your lab out. Saturated again is it contains the maximum amount of solute, and that means we've got amounts that express solubility based upon saturated solutions. So on Thursday, we're going to take a look at some saturated amounts. And it'll give us a specific amount of solute and a specific amount of solvent at a certain temperature. Unsaturated means it can hold more. So most things that we deal with on a daily basis is unsaturated. Very few things are saturated. In my lab, there's very few things that are saturated. And then supersaturated, there's very, very few things are supersaturated. And supersaturated means it can hold more solid than it should be able to hold under certain conditions. Okay, so those are the last. That is section in your book, section 2, chapter 12. And I apologize, I knew I kind of messed up when I was letting my stuff heat up, and it heated up too much. Kind of finicky on that way.